This is page 103 in the red or the yellow book, excuse me, 103, 104 was the homework I gave you. So number 16 on top of page 103 says apples are on sale at the market at 4 pounds for $2. What's the price? So 4 pounds for $2. So how much does it cost for 1 pound? So 1 pound would be 50 cents. So 0.50 of a dollar. Number 17, apples weigh about a pound. How much would one apple cost? So if apples normally weigh a pound, it means that one would cost 50 cents. Okay, we already solved it above. 1 dozen eggs costs $1.98. Okay, a dozen is 12. So what you can do is you want to figure out how much one egg costs. So it's $1.98 divided by 12, and I would definitely use a calculator. So 198 divided by 12 comes out to 0.165. So it's about 17 cents rounded up. 17 cents per egg. Okay, number 19 says 1 dozen eggs costs $1.98. If they charge at the register for only eggs and the tax was $11.98, without tax was $11.88, how many dozen were purchased? Okay, so you paid $1.98 per dozen. At the register was $11.88. So let's figure out how many dozen we got. So 11.88 divided by 1.98. So this would mean I had 6 dozen eggs. And that was for number 19, right? And number 20 says best shoes had a back to school special. The total bill for 4 pairs came out to $69.24 before tax. What was the average price of the shoes? So you paid $69.24 for 4 pairs of shoes. So just divide that on a calculator. 69.24 divided by 4. So your average would have been $17.31 per pair of shoes. Number 21, if you only purchased 2 shoes at that price instead of 4, how much would you have paid? Well, if I paid $2 and for 2 pair and it was average 17.31, that means it's $34.62 what it cost you for 2 pair of shoes. All right, number 22 down at the bottom. We have 6x equals 72, and I also have 4x equals 200. Divide both sides by 6, those cancel. X equals 12. Divide both sides by 4 on this one, so x equals 50. Go ahead and turn the page, take a look at those. So problem 24, we have 3x equals 50. Divide both sides by 3. So x equals 50 over 3. That doesn't reduce, leave it like that. And I get 12x equals $1.98 or 198. Divide both sides by 12. Those cancel. Let's see, 198 divided by 12. Oops. 198 divided by 12 comes out to 16.5 as a decimal. Number 25, I get 12x equals 2580. Divide both sides by 12. Just go 2580 divided by 12, which gives us 2.15. And then I get 1.98 equals 11.88. Divide both sides by 1.98. So x equals 11.88 divided by 1.98 on a calculator. So that comes out to exactly 6. Then I have 1/2 x equals 1731. So what I'm going to do is I'll multiply both sides by 2 to get rid of the fraction. Those cancel. So that's going to give me 3462. I'll multiply that by 2. And I have 1/4 x equals 2. Let's multiply both sides by 4 to get rid of the fraction. So I get x equals 8. And then I have 4x equals 69.24. Divide both sides by 4 using a calculator. 69.24 divided by 4 is 1731. Some of the problems in 22 through 30 above, you did work answer 16 through 20. Write the number of the equation. Number, okay, don't worry about that very last number, 31. All right, so now I need you to turn over to page 110 in the yellow notebook, 110. Okay, so context features. So discrete are just dots. Continuous, you might have dots, but you have a line that connects them. Okay, in your tables, there's really no difference. They're both the same. Your graphs, okay, if you had this, your discrete is going to look like this. Your continuous might have dots, but you connect the dots. Okay, your equations will look the same. And then the domain for discrete have to be either natural numbers or whole numbers. Look at the charts around my room with the circles on it. Okay, and they could also be integers, but your domain of this would be domain of continuous would fall into, you could get away with rational numbers. So rational, if you notice by my charts, goes by Q. It could also fall into the real numbers, which is an R. Okay, so on page 111, let's take a look at that. Set builder notation. So set builder notation looks something like this. That's going to be the x such that x is greater than or equal to 0, something like that. That's set builder notation. Okay, this vertical line here means such that. Okay, it's a fancy word. All right, so problem number 1 down below, if we calculate the slope on our line. So you find 2 points that definitely work. So it looks like there's a point at -3, 1, and also another one at 0, 3. So if we found the slope, and here's your line, I found the slope, we can go vertically. So it looks like I go up 2 and then right 3. So that means I have a slope of 2 over 3. Remember, slope, deal with the vertical and then the horizontal. The vertical is up and down, up being positive, down being negative. Horizontal goes basically right always. Could it go left? Yes, but it's very rare that we have it going left. For number 2, they have n, we have f at n. So we have 4, 7, 11, and 16. Then I have -31, -40, -52, and -67. So this is our vertical component. This is our horizontal component. So if we go from here to here, we have basically -9. And if I go from here to here, it's over 3. So I can reduce that. So I could get -3 over 1. I could also get that just to be -3. And this is going to be our slope. Remember, the letter M is used for slope. They want us to find the recursive and the explicit for problem 2. So our recursive might be like something like next minus 9. And our explicit, we have to be a little careful on here. All right. So I'm going to have both of these. So I have 4, -31, 7, -40. And that's all I need right now. Does this start at 0? The answer is no. Does it start at 1? The answer is no. So this is going to actually have an n-4 in it, so I can make it a 0. And then this is that term. So I'm going to do f at n for my explicit is equal to, I have a -9 difference. So I'm going to go -9, n-4, and then the -31 back here. And that's our whole thing. You can leave it like that. You could try and simplify it if you wanted to, but at this point you don't have to worry about it. Problem number 4, we have x plus 5 is equal to 13, and then we have 2/3 x equals 12. So on this one, I'm going to subtract 5 from both sides. That's going to give me x equals 8. On this one, I'm going to multiply both sides by 3 first. Those cancel. And then I'm going to divide both sides by 2. And 36 over 2 is 18. Go ahead and change the page over to page 112. Oh, there's nothing really on 112. Okay, go to page 113. So I'm going to take a look at problem number 1. Okay, so if we find the slope vertically, you have your line. So they're starting here. So what are we doing vertically here? And what am I doing horizontally here? So it looks like I went up. If you count on your graph on page 113, it goes up 1, 2, 3, 4, 5, 6, 7, 8. So it goes up 8. And it goes right 1, 2, 3, 4. So our slope is 8 over 4, which is equal to 2, or 2 over 1. If I look at my other equation, which is the same line, but it basically does this, this appears to go up 2 and right 1. So I have a slope of 2 over 1. Is 2 over 1 the same thing as 2? And the answer is yes. Okay, so any 2 points on a straight line will have the exact same slope. Skip over number 2 for right now and go into the next page, page 114. Take a look at problem number 3. Okay, so we want to figure out the slope. So I have 6x minus 2y is equal to 2. And then I want to solve this for y. Okay, so first thing they show is they're subtracting 6x from both sides. Those cancel. So I get negative 2y minus 6x plus 2. It's plus 2 because it's positive there. Divide everything by negative 2. So I want y by itself. Those cancel. This reduces to 3x because negative 6 over negative 2 is positive 3 minus 1. This is my slope. My slope is attached to my x. Okay? All right, go over to page 115. Take a look at number 5. It says a freeway construction pours 300 feet of concrete in a day. 300 feet each day. Okay, so if we add days down here and feet here, so day 1, day 2, day 3, day 4, day 5, I'd start here at day 0, I'm at 0, 0, and then I'm going to count this way, I'm going to count by 100. That might be enough. So 300 per day. So the first day, I did 300. Second day, I do 600. Now, let me ask you this. Does it look like it makes a straight line? So I'm pouring 300 per day. So that has to be linear because it makes a line. Okay, I'm pouring the same amount each day. Okay, is it discrete or continuous? Well, let's think about this. Do you think I pour all 300 feet at once, or do you think it goes? I'd say it goes throughout the day. So I'm going to draw a straight line. This means that I have continuous data, okay, because I don't pour it all at once, okay? Take a look at number 7. It says, to meet the demands placed on them, the bricklayers have started a 5% more bricks each day. Okay, 5% more. All right, so this is an increase. We are increasing. So I'm going to change this to 1.05. That's fine. If I were to go and graph this, day 0, day 1, day 2, day 3. So 0 here, and then 5% more. And I don't notice I don't have a label over here. And then 5% more, and then 5% more, and then 5% more. So this is kind of curving a little bit. Okay, I'm making it dotted for a reason. Okay, this is linear or exponential. It's exponential. Okay, because 5% more means I'm multiplying by 5. Or I'm multiplying actually by 0.05. Okay, 5% more today. I would say it has to be continuous because I don't lay all 5% bricks in one thing. So go with that. Go ahead and flip the page over to number 9. This is page 116. The city of Buenos Aires has been adding 8% to its population every year. So this is an increase. Okay, so this, if I were to try and graph something like this, I'd start at a certain number at 0, and then I increase by 8%. And the second day, a bit higher, third day, a little higher. So it looks like that. So our population, this is going to give us exponential because I'm multiplying by the 8% or 0.08. And it would also be continuous because it's not like you just grow 8% instantly. People are having babies, and so, or people are moving to their country. For problem number 11 on page 116, they say we have f at n equals f at n minus 1 plus 3. They then tell us that f of 1 is equal to 5. Okay, so the directions here say 11 to 13 represented, a mathematical representation is provided. State whether the context describes discrete or continuous. Describe it as linear, arithmetic, or exponential. Okay, because I don't have an exponent, this is going to be linear. Okay, I would say it's probably discrete data because it's just numbers we're plugging in. And then finally, create a context to the story that connects each representation. I'm not sure what that would be. But then if you look at number 13, I have g at x is equal to 2 raised to the x times 7. Because this has an exponential right here, this would have to be geometric or exponential. Okay, that's probably the word they're looking for. And then remember the linear up here is arithmetic. So I kind of had to go back on that a little bit. I forgot to say that. And then I'd say this is also discrete data because I'm just plugging values in. It didn't give us anything other than that. All right, so what I'd like you to work on for your assignment is basically on page 113 to page 117, complete all that we didn't do in class. Okay, got it. Let me know if you have any questions. Have a nice day.